Hello, what's up everyone? I hope you're all doing great this evening, where we're going to discover together a new feature of Swift 5.9 called parameter packs. So this time I've written all the code beforehand, so if you want to follow along even during the live stream, you have a link in the description that leads you to a GitHub repo where you have a playground with all the code. Just note one thing, I've noticed that especially near the end of the playgrounds tend to crash when you want to run the code. I think some features, like the more advanced use case of parameter packs, are not handled well by playgrounds for now. That's why, as you can see behind me, I'm using a regular Xcode project for the live stream, but the code in the playground should be correct, unless I've made a mistake, but it should be correct. It's just a playground that's not reliable. So if you want to follow along, I would suggest you do just like I did. So just to show you what I actually did, I created a new iOS project with the SwiftUI template. And you can see I created a file called code, defined a top level function called run, and I'm calling my function run on the on-API of the content view. So we're going to write all our code here. So it's basically a makeshift playground, but it will do the trick. So let's get started and let's talk about parameter packs. But before I start, I just want, as always, to remind you, if you are watching live, first, thank you for being here this evening. But also don't forget that since you are live, you have access to the chat to ask any question, tell me any remark that crosses your mind, and it makes it so much more interesting, not only for me, but also for the people watching the replay, because there is a good chance that whatever question or remark you will have, people watching the replay will also have it. And so by saying it, you're basically giving a voice to the people that are watching the replay. So enough said, let's get started and let's talk about parameter packs. So what are parameter packs? To introduce parameter packs, what I like is to talk about the problem that parameter packs solve. So for this, I'm going to write some code. So actually, I'm going to write some SwiftUI code. So I'm gonna import SwiftUI in this file, like this. If I don't make a typo, it will be even better. Perfect. And let's say, I'm just noticing that actually I'm gonna just move the window a bit, because when I look at the code, I'm looking away from the camera and I find it super weird. And at least for me, like, it's weird for me. So I'm moving the window a bit. All right, now we're good. So let's imagine that we are writing SwiftUI code, the typical kind of code that you write when you do SwiftUI. So for instance, you define a VStack, and in this VStack, you start to put child views. So you put, for instance, a text that says, all right, it displays 1. And if you've written SwiftUI code in what, the 3-4 years now since its release, you might have noticed that as you add more and more child views to a parent view, there is, or maybe there used to be, a limit on the number of child views that you could add. Namely, that limit was, if I remember it correctly, 10 child views. So you would write this code, it would work perfectly, but if you were to add an 11th child view, in the past, this code that I've written would not have built. It would have given you an error that would be a bit cryptic. It would have said something like extra argument number 11 in call, something a bit weird. But the reason was that up until Swift 5.9 and Xcode 15, if you looked at the code of View Builder, so View Builder is the thing in SwiftUI that takes these views that you just declare one after the other and puts them into a structure. This code, this View Builder, would have 10 different overload for the method build block, and it would have one overload with one generic argument conforming to view, a second overload with two generic arguments that conform each of them to view, etc., up to 10 generic arguments, all of them conforming to view. And this is why there used to be this limitation of a parent view could only contain 10 child views at maximum in SwiftUI. But as we've seen, this limit has been lifted because Discord have written builds. And if we look at the code in View Builder, we can see that the signature of build block is quite interesting because it uses 2 new keywords of the Swift language. So it's not every day that new keywords are introduced to programming language. So it's interesting enough to catch our attention. So you've probably already spotted them. I'm just going to move the window so that you can see the full code. So we have the keyword each right here, and we have the keyword repeat. So we can see that this build block, instead of declaring what looks like a generic argument, it declares something which is each content. So it seems to be close to a generic argument, but of course, it's not exactly a generic argument. And then here we have a repeat each content. Same thing here in the return type. Same thing here in the where clause to declare the conformance. And so this each content right here is what Swift calls a parameter pack. And a parameter pack, a good way to approximate what it is to see it as variadic generics. Basically, when you say each content, you say that you will be dealing at the call site with an unknown number of generic arguments. It could be 1, it could be 2, it could be 3, it could be 10, it could be 100, it could be also 0, as we will see a bit after. But this is what parameter packs are. In a nutshell, whereas a regular generic type allowed you to deal with a single type, so one type, and that's it, a parameter pack is more like a vector of generic argument, and the length of that vector will depend on how many concrete type you will use at the call site. Said like that, it seems a little bit high level, a little bit abstract, but don't worry, we're going to take it really like step by step in order to cover this feature and understand it, because it's a feature that takes a bit of time to wrap your head around it, I would say. When I started using it to prepare the content, it really took me some time to really wrap my head around this idea of I'm not dealing with a single type, but I'm dealing with a vector of types, and I don't know the length of this vector when I use it. And it's something that is a bit new actually, because there is no really like equivalent concept in Swift up until now, and as we will see, the fact that there was no equivalent concept means that the syntax to handle parameter packs is also a bit different than what we've seen up until now. That's more than enough for the introduction. Let's go back to our code. So I'm going to remove the VStack right here. And instead, let's say we're going to try and implement a function. What kind of function can we implement? I'm going to paste the code of a function called group in tuple. You can see this function doesn't use a parameter pack. It uses your classic generic argument, so the one we've been used to in Swift for years now. So we have 3 generic arguments, A, B, and C. And as you can see, the function takes 3 values, respectively of type A, B, and C, and returns a tuple whose members are of type A, B, and C. And so basically what it does is that it takes 3 arguments and groups them into a tuple, but does it in a way that preserves type information. And as you can imagine, this behavior is quite similar to what the build block function does in SwiftUI. Build block conceptually does the same thing. It takes an unknown number of views and puts them into a tuple view. It does a few things extra we can imagine, but the big picture is the same. So here I've written a function that works with 3 generic arguments. This means that if I want to create a first tuple, I can do like tuple1 equal group in tuple of maybe like hello YouTube, and then a number just to put a value of a different type. And you can see that this should work if I print to the console tuple1. So let me run the code. So I'm printing to the console. You can see that we indeed have a tuple. but this only works when I pass exactly 3 parameters. If I add another parameter, for instance, a double, you can see that now this time it doesn't build. It says extra argument in call because this my function group in tuple only knows how to deal with exactly 3 arguments. It doesn't know how to deal with 4. And same thing, if I pass only 2 arguments, then this time it's the other error, missing argument for parameter number 3 in call, because once again the function only knows how to deal with exactly 3 arguments. So what we want is to define a new version of group in tuple that this time will be able to work with any number of types. Any number, to say it more specific, to restate it again, I want to define a version of group in tuple, an overload, that will be able to take any number of arguments from 0 to basically infinity, or like a very big number at least, and it will return a tuple grouping these arguments together and preserving type information. So let's go ahead and try to implement it. So I'm going to remove the code and just start fresh. So we still want to implement a function. So the keyword func is still the one we're going to use. Still going to be called group in tuple. And now we reach the part where I need to define the generic argument. So it cannot be a regular generic argument because we will be limited to one argument. We need to have an unknown number of generic arguments. So of course, this is where we want to use a parameter pack. So we declare the parameter pack by using each t. So each t, what it does is that it declares a parameter pack called t that will be able to contain from 0 to n generic arguments. And we declare the parameter pack at the same place than we would have declared a regular generic argument. Then we have to define the argument list for the function. So what is this function? I'm just making sure that you can see. Yes, you can see the full console in the video. I was afraid it would be cut here. So what can the argument list look like? What we want to say is that we can take any number of arguments, and each of the arguments will be of the type of each element in the parameter pack at the respective index. So the first argument will be of the type of the first element in the parameter pack. The second argument will be of the type of the second type in the parameter pack, etc. So in order to express this in Swift, we need to do what is called a pack expansion. So this is where we use the keyword repeat, and repeat, we use it along with a parameter pack in order to expand this pack. I will show you an example, and the reason why it's called an expansion will become clearer. So for the name of the argument is just like a regular argument. I can give it an external name and an internal name. So here I'm calling it value. And so here I want to expand my parameter pack so that value will be able to be any argument list, any list of arguments of each of their own type. And the way you do it is that you do repeat each t. So repeat is what starts the pack expansion. Inside the pack expansion, you can use a parameter pack. And so the way you can see it is that if you call the function passing an int and a string, repeat each t will be replaced by int, comma, string. You call the function passing an int, a string, and a double, repeat each t gets replaced by int, comma, int, comma, string, comma, double. Maybe it's not the same order because I forgot what I said just before, but you get the idea. What you are saying when you say repeat each t is that you want to have the types inside the parameter pack to be expanded into a comma separated list. That's where the name pack expansion comes from. And so here we've defined the argument list of the function, but that's not enough to define the full signature because now we also need to define the return value. And so what will the return value be like? We're going to return a tuple whose member will be of the same type than that of the arguments passed to the function. So we'll return a tuple. And in order to have this comma-separated list of concrete types, as you can imagine, we will do a second pack expansion. So we'll do repeat each t inside the tuple. And so if I call this function with an int and a string, it will return a tuple of type int, comma, string. So a tuple whose first member is an int and second member is a string. Same thing if I add more values when I call the function, and we will do it just after because we still need to do one thing, which is to actually implement the function. So this function must return a tuple. As you can imagine, we will build this tuple using another expansion, but this time it will be a slightly different expansion because here we've done an expansion on what is a type parameter pack. So a type parameter pack is the parameter pack that contains the generic types, the vector of types. But of course, types are only useful if you also have values conforming to the types. And so you have type parameter packs here. So here t is a type parameter pack, but value is a value pack. And we can also expand value packs. And so in order to put the values in the tuple, I will do repeat each value. So you can see that the keyword repeat, its goal is really to start an expansion, a pack expansion, because we've used it here, we've used it here, and we've used it here. But this pack expansion can contain either a type parameter pack, like here and like here, or a value parameter pack, like here. And what's interesting to see, and we will see this mechanism in a good part of the example, is that there is a very strong symmetry between the declaration of the return type and the value that conforms to this type. Because if I remove the return keyword, you can see that the two syntaxes are basically the same, except that the type parameter pack has been substituted by the value parameter pack. It's not a rule that will work every time, but you will see that for a good number of examples that we'll cover in this live stream, this rule is actually going to hold. So it's kind of nice because when you have implemented the signature, then you're basically like, you also have the implementation of the function for free. So now as we have implemented our function, let's use it. So let's try to do, for instance, a tuple of one element. So I will do group in tuple of just an int. And you can see that the type of this is tuple of one and it's just an int. Now I'm going to do let tuple of 2. So it's still going to be group in tuple of 23, and then maybe why not a string that says hello. And if we look at the type, you can see it's a tuple of int string. So that's really the big feature of parameter packs, is that they preserve type safety. And it's very interesting in the case of SwiftUI because, as you might already know, SwiftUI relies a lot on not only on type safety, but also on knowing the types of the entire tree of views in order to, I mean, the way SwiftUI work and some of the optimization that makes SwiftUI run really well rely on the fact that a SwiftUI app can be expressed as a statically typed tree of views. And so I guess what I'm trying to aim at is that you will see as we go more and more into example that this feature is very possible that this feature was created by the Swift team in order to lift a long existing limitation of SwiftUI. And we will see a bit later that when you try to do things with the feature that maybe SwiftUI doesn't need that much, there is a syntax to do it, but it's not the best syntax you've seen in Swift. But let's take things slowly. Let's take things one example at a time, because now I can build on my example and maybe do a tuple of 4. Why not? So I'm going to say hello, hello YouTube. So a second string, and then why not a double? And you can see that we still have statically typed tuple with the 4 types. So that's great because now we are able to implement all the possible overloads with all the possible number of generic arguments by implementing only a single function. So that's super useful, and that's even useful like outside of SwiftUI, because SwiftUI was not the only framework that was limited by the absence of variadic generics in Swift. Frameworks like Combine or like Eric Swift had the same issue. You might have wondered why you only had like zip2 and zip3 in Combine. That was basically for the same reason. And so parameter packs allow these kind of frameworks to lift the limitation that these frameworks had to work around by defining an explicit but finite number of overloads. Now I want to show you something that's a bit interesting and maybe a bit unexpected also, is that when I said that you can have any number of generic arguments, that also includes 0. So if I do let tuple of 0 and I just do group in tuples and I pass in no value, I try to build my code, you can see that the code builds. I have a warning that tells me that tuple of 0, is an empty tuple, so it's basically void. So you have a warning to tell me maybe that's not what you want, maybe you made a mistake. But it's actually possible to provide 0 values when you are using a parameter pack. So that's useful because sometimes that's exactly what you want. Think, for instance, of SwiftUI. In SwiftUI, you are allowed to provide 0 child views to a view. You can declare a v stack or an h tag that is empty, and actually View Builder will automatically transform this into an empty view. But there are also cases where you might not want that. For instance, if I remember it correctly, still in SwiftUI, the scene builder, so where you declare the scenes of your app, you are not allowed to provide an empty number of scenes because it doesn't make sense. And so it's actually possible with a parameter pack to still force to have at least one value. And the way you do it is pretty interesting. So I'm going to do it by taking as a base my function group in tuple, and I want to call it this time group in non-empty tuple. And what you want to do, since the parameter pack can take from 0 to n generic arguments and you cannot control it, what you do is that you define explicitly your own generic argument. So since the parameter pack covers 0 to n generic arguments, if you add your own, then when you do the sum of the two, it covers from 1 to n plus 1, but since n is like a very big number, it's just like n and n plus 1 is basically the same thing. And so you do it this way by defining your own type. So it would look like this. You add the generic type here in the declaration of the generic arguments, and then you add a first argument here. So actually, let me rename it to first. I think it will be even clearer. So first is of type first. In the return value, you return a tuple that will be a first and then the pack expansion, which could be from 0 to n types. And same thing here, you build a tuple by providing the first value that you know will always be there because it's not an optional value. You have to provide it. And then you do the expansion of the value pack. And so if I go now and I try to build another tuple of 0, but this time using group in non-empty tuple, so I pass no arguments, as you can see, I will get a compilation error that will say missing argument for parameter number 1 in call, because I need to provide a value for this argument. It's not optional. So it's good to have this in mind, because when you use a parameter pack, I think like you tend to think, okay, I can use any number of generic arguments, and so you tend to think that that number is going to start at 1, but actually no, it starts at 0. And it's actually a good thing, because as we've just seen, when it starts at 0, it's very easy to make it start at 1 instead. You just need to define explicitly one extra generic argument. However, if it were to start at 1, then making it start at 0 would be much more complicated and maybe even impossible. So it's an interesting design decision, but that makes a lot of sense when you think about it. Okay, now we're going to start and build more complex functions using parameter packs. So let me see. I'm going to remove all the code so that we have every time something that is clean. Remember to have all the code in the GitHub repo that is in the description. So now I want to implement this function. I call it wrap in array, and this function will take any number of arguments and will wrap them into an array that will contain a tuple with all of the arguments. So this operation seems a little bit like artificial. You might be thinking, what's the point of putting a tuple into an array? There might not be a real world use case of it, but my goal here is to show you step by step how we can use the parameter pack syntax to build increasingly complex stuff. So we are iterating up until the point where we will start building stuff that you can use in the real world. And the last example I have for you today, by the way, is something I used at work last week, and that is quite useful when you use SwiftUI and the environment. So the last example will be worth the wait. Plus, you will also be able to understand how the last example works when you will have seen all of the intermediary steps. So let's try to implement this function wrap in array. By the way, if you're wondering why the example mentions Swift Island, is because I first prepared this content for a workshop I gave at Swift Island, which is a conference that happened in the Netherlands at the beginning of September, and it's a great conference. I can only recommend that you check it out. Really great conference. I had a great time there. I see some new people coming in the chat. Good evening, Eve. I see I have a fellow French person following the live stream. So let's try and implement the function wrap in array. So what do we need to define, to define this function? First, we're gonna need, just like for grouping tuple, a parameter pack, because we want to be able to pass an unknown number of arguments, each with their own generic type. So let's declare this parameter pack, each t. Okay. Then we need to define the argument list. So we're going to receive values, a list of values. So actually, it's just like before. We're going to receive values, and to define the type of this argument, we're going to do a pack expansion. Just like before, we say repeat each t. You might be wondering why I'm using value in the singular, why I'm not writing values. And it's because when you use value inside the function, you're going to say repeat each value. And it makes more sense to say repeat each value than repeat each values. So the kind of like convention that seems to exist is that when you define an internal name for the argument, you do it in the singular, because inside the function you will say repeat each value. And if you were to define an external name, then you would put it in the plural, because at the call site, you are providing several values. You would say wrap in array values 23, hello, Swift, island, etc. So it's interesting to note this. It's purely made to like make readability a little bit easier, but I find that it's a nice convention, because saying repeat each values, it's even a bit confusing, because you're wondering, are we repeating like all the values several times? You know, it's a little bit less clear. So value repeat each t. Then we need to define the return type. So I say I want to put the values in a tuple. So actually, just like before, so to build the type of the tuple, it's a tuple type inside of which I do repeat each t, just like we did before. And I want to return an array that contains the tuple. And the way I do it is that I define and I declare an array, just as I would have done before in any kind of Swift code. I need to provide the generic argument to array, because array expects a generic, array defines a generic argument for the elements of the array. And for the generic argument, I pass my type, my pack expansion. So what I want to show you with this example is that it's absolutely possible to use a pack expansion where another type expects a generic argument. So you can basically use pack expansion and pass them to other types. And so this way you can build increasingly complex structures. And what's nice is that array doesn't use a parameter pack at all. Array, it just has a generic argument that is called its element, and you can pass the result of the pack expansion because the result of the pack expansion is just a regular type. When you give it an int and a string, it will be a tuple of int and string. You give it an int, a string, and a double, it will be a tuple of int, string, and double. But the result of the pack expansion is a regular Swift type. And so that's something that is very important to understand, is that as soon as you do a pack expansion, the notion of having a parameter pack disappears because you can see this as an expression whose return type, so you can see the repeat each t as an expression whose return type is a new type. And so when I write tuple of repeat each t, it returns a concrete type. And so I can use this concrete type any place that I can use a concrete type. And one of these places is to pass a value for a generic argument of a type that declares a generic argument, like array, for instance. So we are almost there. We just need to implement the body of the function. And just like I said, the body is going to be on a nice symmetry with the return type, because we want to return an array. And in this array, we want to have our tuple, and we build the tuple by doing another expansion, this time of the value pack. So normally, if I haven't made any mistake, this code should work as expected. So if I run my code, I should see in the console an array that contains one tuple with 5 members that are of type int, string, 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 and also string. So let's see. If I print the result, it will be even better. When I told you I had written the code in the playground first, you can see an example of it. Okay, so you can see it has worked as expected. So we've been able to build a slightly more complex structure using our parameter pack. I see a question. Vincent, are you recording this? I like to come back to this tomorrow when I'm sober. Don't worry, it's being recorded. There will be a replay available as soon as the live is over, as always. So don't worry, you can leave and you will be able to come back to where you were tomorrow. And I agree. This content is already complex to understand when you are sober. So when you're not, yeah, it's a bit of a challenge. It might be even too big of a challenge. At least I wouldn't have tried it myself. Okay, so let's see. What did I have next? Next, I want us to do the opposite. So we have implemented wrap in array that would put the values in a tuple and wrap that tuple into an array. This time I want to do the opposite. I want to return a tuple whose members are the individual values passed as argument, each of them wrapped into an array. Once again, it's a bit artificial, but you will see that it's going to allow us to see an interesting point, an interesting element of the syntax. So I'm going to keep the original wrap in array this time because it's useful to have the two of them to be able to compare. So this time I want to implement other wrap in array that takes the same argument list. So it takes any number of arguments, and you can see that whereas wrap in array would put the arguments into a tuple and then wrap that tuple into an array, here it's the other way around. We wrap each element into an array, and then we put all of the arrays inside a tuple. So let's see how we can build this new function that I called other wrap in array. So for the parameter pack, it's still the same thing. It's still each t. Nothing has changed there. For the arguments that the function will take, it's also the same thing. You can see that the logic is the same for other wrap in array than for wrap in array. So it's gonna be an argument called value and repeat each t, we do a pack expansion of the type parameter pack. Now where things become interesting is for the return type, because this time we want to switch things around. We are no longer returning an array that contains a tuple, but a tuple that contains several arrays. So let's try to write it. First, we need to return a tuple. So let's start by defining a tuple. And then this tuple is going to contain several arrays. So let's see how we could define this. I guess if you need to write this, there is a good chance that your first intuition will be to declare an array, and then inside the array, do repeat each t. So let's see what happens when I write this. You can see we have an error that says pack expansion repeat each t can only appear in a function parameter list, tuple element, or generic argument list. Because here we are saying that we want to build an array of types, but it doesn't make sense because you cannot you cannot do that. Array expects only one generic argument. You cannot pass it a list of generic arguments. And so what you need to do in order to implement what we want, so a tuple that contains array and each element of each array type is the same than the types of the arguments passed as the call site, we need to take the repeat keyword and move it out of the array. And this time, it makes much more sense to the compiler and also hopefully to us, because what we're saying is that we are doing a pack expansion. We start it with the keyword repeat, and then we say in this pack expansion, we want to build not just a comma-separated list of the types used at the call site, but we want to do things with this type. And so we want, namely, to wrap them into arrays. And so with this syntax, instead of generating a comma-separated list of the types, we are generated a comma-separated list of the types, each of them wrapped inside an array. And the syntax element I wanted to introduce with this new example is the fact that repeat and each don't need to always be next to each other. When you see either videos from WWDC or articles that talk about parameter packs, usually they will show you only the most simple example because, I mean, they don't have the time to deep dive into all the details, and so you will always see repeat each and then the name of the parameter pack all together. But when you want to build more complex thing, you will need most of the time to have things slide in between the repeat and the each, and so that's what I wanted to show you with this example. And I see, Bala, you are enjoying the tutorial. Thank you for sharing it. I'm very glad to hear that you are enjoying this content that is challenging. So it's always like when I do this kind of content, I'm always like, is it going to work well or am I going to sound like a crazy person? I'm glad to hear that you're enjoying the content. And so we've defined the signature of the function. And remember what I said, most of the time, the implementation of the function will be just a mirror of the way we implemented, or rather we declared the return type. So let's see if it's still true. So we want to return something. We want to return a tuple that contains arrays, each array containing the values passed as an argument. So it seems that indeed we need to do repeat. And then we're going to repeat to produce arrays. And each array is going to contain one of the value passed as an argument. So once again, we have this very interesting symmetry, which becomes even more apparent if I don't have the return keyword. But if I don't have the return keyword, there is a bug in Xcode that doesn't color repeat as a keyword, so I find it even more confusing. So I will leave the return keyword so that we have a nice color syntax, a nice syntax coloring, rather. Okay, so normally this should work. So let's try and print this to the console and let's see what's gonna happen, but normally it should work. Yep, it works. So you can see, read the difference. You can see that we have basically distributed the array over the elements of the tuple, because the array used to be outside and now each element of the tuple is wrapped into an array of its own. And in a way, I was saying kind of, but when you think about it, it's what we've done basically. We have distributed the generic argument, the generic type array over each of the members of the tuple. And by doing so, we've seen how to build an even more complex syntax using parameter packs. But we are not going to stop here, because now we're going to use parameter packs with generic conformance. Kind of like what we saw briefly with SwiftUI at the beginning, because SwiftUI was using a parameter pack, but with the condition that each type in the parameter pack had to conform to Vue. So we're gonna try and implement something similar. So let me remove the code so that we have a clean slate. This time, I want to implement a function called first, and what it does is that it takes an arbitrary number of collections and it returns a tuple whose member contain the first element of each of the collection. So this is something, if you want to preserve type safety, that you need parameter packs for, because even if you were to use any collection as an argument, you wouldn't be able to define a tuple whose member are statically typed to the elements of each of the collections. So for this first collection, the element is int. For the second collection here, the element is of type string. So let's go ahead and try to implement this function. And you will see that we're going to need to do, once again, an even more complex usage of the parameter pack syntax. So the function is called first, which is more difficult to pronounce than I had in mind when I decided for this name. So this time we need to define a parameter pack, and we need each concrete type that will be part of this parameter pack to conform to the protocol collection. So there are two ways to do it. I will show you the easy way here, and I will and the other syntax later. So the easy way to do it is to do just like you could do with a generic type, actually, a single generic type. You know, you could do T and say that T must conform to collection. So using the, how do you call this in English? I've forgotten. I think it's colon, but I'm not 100% sure how it's called. I think it's colon. Using the colon character to say T must conform to collection. We are expressing a condition, conformance condition on the generic. So you can write this for a regular generic, and you can also write it for a parameter pack. So when I write this, I'm saying that each type in my parameter pack T must conform to collection. Okay, it was colon. Thanks for confirming. So I think this is colon and this is semicolon. That's how I find colon back, because I was like, this is called semicolon, and so that's why. Which actually different than in French. In English, you say colon and semicolon, and in French, this we call it like dot comma, so point virgule. We really say like what's written, like we describe it like the one on top, the one on the bottom. So it's a bit different in French than in English. That's why I got confused, I think. So back to the topic. So here I'm saying all of the elements of my parameter pack must conform to collection. So for instance, if I pass something that is not a collection, it's not going to work. Interestingly, we will try it later. What happens if I pass a string? Because I think string conforms to collection in Swift. Like it used to be the case, then no longer the case, then back to it. So we will see like how it is. But at least that's what I want to enforce on all of the type in my parameter pack. Now it's time to declare the arguments the function will take. So here actually there won't be that many changes, because before we wanted to take any number of values. Here it's still the same. What has changed is that these values have to be collections, but we've already expressed this here, so nothing is going to change actually in the way we define the argument list. I mean, the only thing that changes is the name, because I'm not going to call it value anymore. I will call it collection. It's going to be more descriptive. But I will still do a repeat each T. Like that. All right. Now we have to define the return type. And this is where it's going to be more interesting. because we want to return a tuple. So by now we know that when we want to return a tuple, the first step is to just declare a tuple. Now we need to return a tuple whose members are of the same type than that of the element of the collection we passed as an argument. So we need to access the associated type element of the collection. I'm going to command click on collection I'm going to command click on collection just so that we can get our mind like refreshed on what a collection is. So collection is a protocol, and this protocol has an associated type called element. And it's also a primary associated type that you can see in this syntax. And so we want to retrieve the element of each of the collections that we've passed as an argument. So for this first collection, we want to retrieve the element which is an int, and for this one, the element which is string. And I see a question in the chat: am I French? Yes, I am French. And the way we do it is that we're going to use an expansion in which we will access the associated type of the type in the parameter pack. So it sounds a bit complex, but when you see it written, it becomes slightly more obvious. So we start with repeat because we want to do a pack expansion, and what we're gonna do is expand so the types in the parameter pack. So with this, we have a comma separated list. So it would be collection of int, collection of string, for instance. Then I don't want to have collection of int, collection of string. I just want to have int and string. And so I need to project to get the element. And the way you do it is that you put each t between parentheses, and now you can use dot to call things on each of the types in the parameter pack. And among the things you can call is the associated type element. So what's a bit annoying is that if you do escape, you can see that the completion doesn't help you, even though it's absolutely valid to write like this. And so this here is going to return a tuple whose member will be of the type of the element of the collection we passed as an argument. So a little bit complex, but once you've wrapped your head around it, you can see the idea. And so what we've seen here is that we can, inside a pack expansion, call things on the each t, so on each of the types inside the parameter pack. I see a question in the chat. Before I answer it, I will finish implementing the function first because we still need to implement the body of the function. And just like before, it will be a mirror of the way we declare the return type. So we want to return a tuple. In the tuple, we do a pack expansion. This time we will expand the value pack. And so just as we did above, we will put in parentheses each collection. And now on each collection, we can call whatever we can call on a collection. For instance, we can call first, which returns the first element of a collection. It returns an optional. Since I don't want an optional, I'm just going to force and wrap. And so normally, we've implemented the method, or rather the function first. So let's try and run the code, and let's see if it works as expected. You can see that it does. We have a tuple that contains the first element of each of the collection. And so if I try to pass a value that is not a collection, you will see that. So I get a bill succeed. Oh no, that's because I added like this after. So it's an extra argument to print, and print can take any number of arguments. I wanted to add it here. And of course, now it doesn't work because local function first requires that int conform to collection, which is not the case. And let's say just if I put a string, this time it works because string in Swift is a collection. So if I run the code, you can see that we have the first letter of the string because string conforms to collection in the current version of Swift. So let me see your question. Jan, you were saying, Vincent, this seems like a super complicated way to do something you can use map for. Very, very, very good question. Very good question. So And as with every very good question, the answer is going to be not all black, not all white. There is a lot of subtlety here. Is that indeed this could have been implemented using map. But if you had used map, the best you could have done would have been to return an array, but it would have been an array of what? An array of any. Because in an array, you cannot put both an int and a string. I mean, you can do it, but the way to do it is to say that your array is of type any, or to use an enum with cases with associated values. But you would have lost type information. That's the point I wanted to get across. And so the use of parameter packs is mostly in situations where you don't want to lose type information. But if you have this kind of use case in an app, indeed, it's possible that map will make more sense. So in these examples, I don't recommend that you implement them as is because they are more here to teach you about the feature than because they are extremely useful in the real world. However, the point I really want to get across is the fact that the added value of parameter packs is that they preserve type safety. As you said, you could achieve the same thing using map and using any, but then you would lose type safety. So it's a very interesting remark because drawing this parallel is super interesting and super insightful, but parameter packs still have an added value. But there might be cases where the added value is not something that you need. And so maybe you could have done just any, you could have written it by saying, okay, here I'm going to do like something like any collection ... something like that. And then you return an array of any, and that's enough for your use case, for instance. That could be very possible. But the two codes would not be equivalent because you would have lost information. And that also allows me to go back to the way the pack expansion work. The pack expansion, you can really see it. So when you use the repeat as something that is happening very early in the compilation process. Basically, you can kind of see it as a compiler taking your call site and manufacturing a function using this as a blueprint and your call site as the input. So the compiler takes your input and is like, okay, here the parameter pack has 3 types, and so I will build an overload of the function first on the fly that conforms to this that conforms to these 3 types. I might be simplifying a bit what's happening, but conceptually, you can really see it like this as something that is happening early in the compilation process. And so it's kind of like using a map, like you said, but you do it in a way where the compiler can still reason about it without losing any information on the types that are involved. And what I wanted to say by that, and I didn't say it even though it's the most important thing, is that when you use map, the operation you describe, they happen at runtime. Whereas when you use a parameter pack, the operations, the pack expansion happen at compile time. And so that's why you have a better safety and more information preserved when you use a parameter pack, because parameter packs, they are a compile time operation, whereas using map is a runtime operation. That's the way to answer this with the shortest sentence possible. So great question. Thank you for having asked it. Great question. So I told you that there is another way to write the function first, and we're going to do it before we move on to the next part of this tutorial. So this time I want to implement an alternate first. It's going to do the exact same thing. Nothing is going to change except that I told you there are two syntaxes to define the conformance condition here. So the fact that every type in the parameter pack must conform to collection. I used the easiest one, which is at the same time that we declare the type, we use the colon to say each parameter in the pack must be a collection. But we could have also used the other possibility we have in Swift, which is to use the where keyword. And we would have said where repeat each t colon collection, like this. These two syntaxes, so this one here and this one here, do exactly the same thing. The one with the where clause is slightly more complex because you have to do pack expansion explicitly, whereas when you do the shorter syntax, the expansion is kind of like implied. But they do the exact same thing. And just like when you declare a generic argument and you want to add conditional conformance, you can do it at the place of the declaration or using a where clause. You can do the same thing with a parameter pack. So I just wanted to show you that both syntaxes were possible. I see a question. Sorry, I know that this question is not related to your life, but I'm passionate of computer science. What courses do you recommend? Really good question. What I used a lot back in the days, I say back in the days, it's more than 10 years ago now, something like 12, 13 years ago, but it was all the courses that were available online from MIT and Stanford, all of their computer science courses, like from the basic ones, and then you increase in complexity. I found they were really like top quality, available for free. Back then, they were available inside iTunes University, but since then, iTunes no longer exists, and same thing for iTunes University. But I think like the content is still available on YouTube or on the website of Stanford and MIT, and so like their CS classes that are available for free, they are really great content, and definitely something that I would recommend. Probably I wouldn't be doing what I'm doing these days if I hadn't been watching these courses something like 12, 13, maybe 14 even years ago. No, I think it was in end of 2010. So only 13 years ago. Okay, where are we in what I had planned? I think we are like halfway. I thought this would take only 1 hour. It's taking a little bit longer, but that's a good thing because at least we can explore and take our time. So now we're going even more complex things. I want to implement a function called make pairs. So let me see if I have the syntax. Yes. So this is what I would like this function to return. So you can see that this time the function takes 2 argument lists, not 1. And what I want is to return a tuple whose members are tuples, and each of them contains the first, then second, then third, fourth, etc. argument passed. So you can see that the first tuple contains the first argument of the 2 argument list, then the second tuple contains the second argument of the 2 argument list, etc., etc. So with this example, we are introducing how to deal with more than one parameter pack inside a single function. And this is kind of useful because this is implementing basically kind of like a zip function that you could start you can start finding a real world use case for this kind of code. For instance, you could imagine that this could be used in a testing code in order to define inputs and expected outputs, or actual outputs and expected outputs, these kind of things. So let's try and implement this function. By the way, if you're watching the replay, it could be a good idea to like pause it and try to implement the function by yourself. Because normally, if you use everything that we've seen up until now, you should be able to implement the function. There is no new syntax to implement this function. There is a new way maybe to use syntax we've already seen, but it should be doable. So if you are watching the replay, maybe pause it for like 5 minutes, try to do it by yourself, and then resume to see the answer. And if you're watching live, let's do it together. So we want to implement this function called make pairs. So I was telling you this time we need more than one parameter pack. That's not a problem because just like you could define more than one generic argument, you can also define more than one parameter pack. So I will define a first parameter pack that I will call first, and a second one that I will call second. So I've defined 2 parameter packs in my function. Now I need to define my 2 arguments. So we can see that it's the same idea than before, except that whereas before we were taking only 1 argument, this time we are taking 2. And so that's why we need to have external names for the arguments, because Swift requires you to have external names in that case, because if that wasn't the case, Swift wouldn't be able to know where the first list ends and where the second list begins. Actually, I think you might get away with not providing a name for the first one, but for the second one, you need a name, because otherwise Swift doesn't know where to draw the separation between the two lists. So let's implement these arguments. So you can see I gave them the external name firsts with an S. I'm starting to speak French. But for the internal name, I will use first, because as I've said, when we are inside the function, we want to say repeat each first, and it makes more sense to say that than to say repeat each first. So the first argument will be repeat each first, with a capital F for the type. So just what we were doing before, except that now we have given an external name to the argument, but before we would do underscore value, it's the same ID. And there are no tricks for the second argument list. We just say seconds, we call it second inside, and we do repeat each second. So this is how you define these two argument lists. For now, these two argument lists can take an arbitrary number of arguments, and the argument list don't need to be of the same size for now. Of course, for make pairs, they will need to be of the same size, but for now, the constraint that they must be of the same size has not been defined. I see a question. Is it possible to just do a return? What if I want to process each and every parameters differently based on condition? When you say to just do a return, I'm not sure what you mean. Do you mean that you would like to be able to iterate over the values? If that's the case, we're going to get to it a little bit later, because indeed, up until now, we are just returning tuples, but returning tuples, what do you do with these tuples? How do you iterate over the values inside the value pack? That's a very good question, and we will get to it quite soon now. There are still a few examples, but we're getting to it. Yes, iterate. So yes, it's coming, and you will see that the syntax to iterate over the value of a parameter pack, the value of a value pack rather, the syntax is quite interesting. Brace yourself, because you will see that it works, but it's one hell of a syntax. So make pairs. Let's get back to it. So we've implemented the list of arguments. Now we want to implement the return type. So this return type, you can see an example here. It's a tuple that contains tuples for its member. And that's where there is something slightly new, is that up until now, when we used a repeat, the repeat, so the expansion, would contain one each, but a single each. But actually, that's not a limitation. A repeat, a pack expansion, can expand more than one pack at a time. And that's what we're going to need to use now, because we want to repeat to have several tuples, each of them being of the types inside both parameter packs. So we need to do repeat and then define tuples. So up until now is the same logic when we were returning a tuple of arrays, is the same logic. What changes is that we do inside this tuple each first and then each second. So we are expanding two parameter pack at the same time, and this is what will give as a result a tuple, and in the first member of the tuple, a tuple of int and string. Same thing for the second one, and then for the third member of the tuple, a tuple of string and int, etc. So this is this approach of using two parameter packs inside the same expansion that I wanted to introduce with this example. And it's when I told you that I also need both argument lists to be of the same length. What is going to implement this requirement is the fact that I'm using both parameter packs inside the same expansion. When you use two parameter packs inside a same expansion, then the compiler will enforce at compile time that the two parameter packs are of same size, because otherwise, or same length, because otherwise it's just not possible for the compiler to expand the two of them at once if they are of different length. Okay. So your finger syntax looks weird to you. So it's indeed a weird syntax, because we are handling several generic arguments at once. So there is something like intrinsically weird with this syntax. And you're saying, can we improve it using some? That's a good. You can't really. So I see what you mean, because some is kind of like, it serves a purpose that is kind of similar to parameter packs in the sense that it's also an operation that happens at compile time and that helps introduce more type safety with a simpler syntax. But some does something different. Some is just like an alias for a concrete type. When you say some view, it gets replaced at compile time by the actual type of the view, which could be very long because SwiftUI nests types into each other. So it's really like an alias. So saying repeat each sum first, I don't think it would make it would solve something. So if you have like more details in mind, feel free to say it in the chat. But for now, I don't see how we could use it. And thinking about all of the examples like I've seen when I was preparing the content for this live stream, I don't think I've seen some being used with parameter packs. So I wouldn't say that there are two features that necessarily like work particularly together, even though they do serve like the same purpose of making generics more powerful by introducing operations that happen at compile time. So we are almost there for make pairs because we've implemented the declaration of the function here. And remember what I said, the way we implement the function is often a mirror of the way we define the return type. So let's go ahead. So return, we return a tuple, repeat, and then each, this time first with a capital F, and each second. So same logic than above, but instead of handling the types, we use the values conforming to those types. And so normally we've implemented the function make pairs, and I've called it make pairs, but I've called it zip. It would have done the same thing basically. And as you can see, it works as expected. So I see some questions. Let me have a look. Can we use multiple repeat each statement in the return in case we want to add a constant number of parameters between the packs? Can I do it? So can we do multiple each? You mean if you want to add, if you want to interleave the pack expansion with other types? I don't think you can. I don't think you can. At least I haven't seen how to do it. The way I see it is that when you expand the pack, it's all or nothing. Like you take the pack and you cannot like interleave things in the middle. You can put things before or after, but in the middle, I don't think you can. At least I haven't seen syntax that would allow you to slice a parameter pack. So I don't think you can. Or do I use the same repeat statement and just avoid adding each for the non-packs? Yes, that would be more of this approach. Like what is not in a pack, you put it either before or after, and you don't put it within the each. So that would be the approach I would recommend. And it's kind of what we saw at the very beginning of the live to see when we want the function to force it to have at least one value, because the parameter pack can be zero value or zero types. That's kind of like what we did in this very first example. So let's see, you say, Yann, that you have the examples here. So the first one, it would be add entries, entry, which will be collection of mail map entry, okay, and the mail, okay. Looking at it, I'm not gonna lie, I think it requires a bit too much context for me to go into the details during the live stream. So what I would say is maybe like add a comment on the replay so I can have a look at it like afterward, and people can also have a look at it and maybe suggest you things. But during the live stream, I think it's going to be a bit too complex for me to deep dive into this example. And I see a comment written in what seems to be like Cyrillic that mentions C++. So I'm afraid I can't read Cyrillic and I don't have a translation feature on my streaming software. So if you can write your comment in English, please do. if it's about the fact that it's kind of similar to generic arguments in C++, yes, it's a bit similar, even though it's not as powerful as generic arguments are in C++. But if you can translate your comment in English, I would be very curious to read it and to answer to what you had to say. So we've implemented make pairs. That's right. That's right. So we are getting almost all the way there. What did I want to show you then? Oh, well, we are getting to the moment where we will need to start iterating over the values inside a parameter pack. So that's going to be interesting. That's going to be very interesting. So let's go ahead and do this. This is what I want to implement. I want to implement a function called total count that takes any number of collections and return the total count of items inside all of the collection. So a sum of the count of each collection. So here it will return 3. Here it will return 3 plus 2, 5. And here 3 plus 2 plus 3, 8. This is a typical example of a place where you could implement this using any collection and map at runtime. So here, my goal is not to say that you should use a parameter pack when you want to write this kind of code, is to find an example that is simple enough that we can iterate over values. So that's just wanted to get that point across. So let's try and implement this function total count. So just as before, it's a function. I use the keyword func. I define the identifier of the function. I need to define a parameter pack, so it will be similar to what we did with the function first, because we want to take any number of arguments, but each of them must be a collection. So I'm going to say each C, and then each type in the parameter pack C must conform to collection, just like we did before. For the list of arguments, is going to be just like before also. So we're going to take an arbitrary number of collection, and so repeat each C for the type of the argument. But for the return type, it's going to be a bit different, because up until now we were building the return type using an expansion of the parameter pack, but here it's not the case, because we are aggregating values, and so total count is just going to return an int. The question is now, how do we compute that int? So let's imagine the way we would aggregate values in Swift. So we would probably start by defining the result variable, give it an initial value of 0. At the end, return the result. And here in the middle, we need to do something. We need to iterate over the values inside the value pack. And your first instinct might be to do something like for C in collection, something like that. But you will learn that for now, there is no for loop for value packs. So you cannot write this. There is actually a Swift evolution proposal open to add this syntax, but for now, that's not the case. What's interesting is that if you read the Swift evolution proposal this time for parameter packs, you will see that it says that it's still possible to iterate over the values of a value pack. And the way you do it is quite interesting. So when I was telling you that it was going to be an interesting syntax, is that we are going to do an expansion of the value pack, so the collections. We're going to create a tuple, and each member of this tuple will be a side effect that will be incrementing result with the count of each collection. So like that. So when you read it, it seems like to make sense. We repeat each collection, get the count, and add it to result. And if I print the result of the calls to total count, something like that. So this is where a playground would have been nice. Unfortunately, playgrounds crash when you try to use this think it's for this syntax of iterating where it starts crashing. So let me run this code. Normally we should see 358 in the console. So we do see 358. And as you're saying, Bala, it's a beautiful piece of code. So what's nice is that I declare the tuple to make it more clear what's happening, but Swift doesn't force you to declare the tuple. You can just say repeat result plus equal each collection.count. So when it's just a one-line operation, it seems like okay, like it's something that we can live with. But of course, some operations might require more than one line. How do you do if you need to have several lines inside what is the equivalent of your for loop? You can do it, actually. There is no problem for this. You can just define, and when I say you can just define, it's what actually the Swift efficient proposal says. It says like, since every code written here can be put inside an inner function, technically, you can iterate and do anything that you want. So I define an inner function. This inner function will have a generic argument that will also conform to collection, but this time it's a single generic argument. If you read the Swift efficient proposal on parameter packs, you will see that they use the term scalar generic argument, which makes sense because I was telling you that parameter packs are like vectors. If parameter packs are like vectors, then it stands to reason that regular generic types have become scalar generic types. So we have our scalar generic type that conforms to collection. And what we can do with this inner function is take a collection, so of type T. Actually, you know what? Here we could do some collection because that's a use case where we don't need to explicitly define a generic type. We can just do some collection. It would work. We're going to return an int. We will take the code that was here and basically move it. So we will just return c.count. And so here, what we'll do is that, let me get it straight, we will do each inner, and for the argument, that's where we pass the collection. Does this build? No, it doesn't build because I didn't write it correctly. I never remember where you need to put the... That's a good thing that I have the solution. How am I supposed to write this? Okay, so it's repeat, but just I need to move the each to be here. Okay, so it makes more sense when you think about it that there is this tuple that is like around this expression. This way it seems like more, it makes more sense that the repeat is all the way to the left. And so if I try to run it, I'm starting to get tired. You can see that it's still working as expected. And so inside our like makeshift for loop, we can run more than one line of code by putting the code inside an inside function. And so yeah, repeat pattern where pattern is each type. And so inner each collection. Yes, that was the correct suggestion. Great job. And so you can iterate over the values inside a value pack. Just the syntax is not super great, but brace yourself because it becomes even worse. Because here we wanted to implement the kind of loop where you always want to go through over all of the elements. But not all loops are like this. For instance, let me remove this code. And let's say that I want to implement this time a function that is called r equal. So this function takes two tuples and returns whether or not the two tuples are equal. So let me format it so it's a little bit easier to read on the screen like that. When you implement this kind of function, you would want to do what is called a short circuit evaluation, meaning that as soon as you found two values that are not the same, you want to return false immediately, because as soon as you found two values that are not the same, you know that you will return false anyway, so it doesn't make sense to even look at the rest. You save time, and it won't change anything to look at the rest of the values. But how do you write this kind of short circuit evaluation when you have this makeshift for loop where you cannot break because you don't have a for loop. You cannot break. What we have written, we are creating tuples. Each tuple, each member of the tuple was a side effect, and all the side effects were being executed no matter what. As it turns out, it's still possible to implement this short circuit evaluation. So let's try and implement the function r=, and you will see it's gonna be very interesting. By the way, this is the penultimate example of this live stream. Then we will move to the final example, which I think is the best one, is really like the killer app. And we will have covered everything to get started with parameter packs. So let's implement r=. So it's a function. As you can imagine, it defines two parameter packs. Actually, no, it defines a single parameter pack. And that's a very important distinction because, of course, we need the types to be the same. Because, I mean, if I put here an int and here a string, we know straight from the beginning that they are not equal. We can even say it at compile time that they are not equal. So we define a single parameter pack. I'm gonna call it like element just to change a bit. And this time I have a requirement which is that each element must be equatable. So it works because int is equatable and so is string. And notice that what is really great with this syntax is that each type needs to be equatable, but you can have different types, which would be very different if you hadn't been using a parameter pack. Because if you hadn't been using a parameter pack, you could write this, but then it would only work when all of the things you are comparing are of the same type. Here, we no longer have this constraint. We can have different types as long as we use the same type on the respective indices of each of the tuples. By the way, if I've defined tuples, but it could be just like, you could do the same thing with just like comma separated values. I don't know why I put tuples, like it complexifies the thing a bit, but there is no real like reason for it. And you're saying, Yash, you could return, so for the total count, current value and iterator. That's an interesting one. I hadn't tried it, but I guess you could do something like this, so kind of like of a reduce approach in a way. Maybe you could do it. The trick is in that case, because I tried to do it, the trick is that on an iterator in Swift, when you call next on the iterator, it's a mutating method next. And so you could have an issue because I tried to do this in some examples and it wouldn't work because it would consider iterator to be a let constant and you wouldn't be able to mutate it. So it might not always work, but I see your ID. Maybe if I have time, I will try to do it. But look at the one I'm going to show you because like it's worth seeing. It's like, you know, like the kind of thing that you want to see like once in your life, or like, you know, like when there is a car crash, you shouldn't look at it, but you feel drawn to watching at it because it's just like too awful. So get ready. So I've defined my parameter pack. Now I need to define the two arguments that I receive. So I receive on the left a tuple that will be of repeat each element. So I'm expanding the type parameter pack. I will do the same thing for the tuple on the right. So this is the left, this is the right. Of course, when you display the code like this, it's top and bottom, but still it's left and right when you think about how you call a function one argument after another. So here, same thing, repeat each element like that. And for the return value, it's just a boolean because either they are all equal, so all of the elements on the same indices are all equal or not. So let's see. How can we implement this? The way we do it, and I'm just going to, you know what, I will just copy and paste the code because it's better if you discover it at once. It's even better. So it looks like this. What you do is that you define an inner function that will throw if the elements are not equal. So I forgot you also need to define a struct. I mean, you need to define something that conforms to error in order to have something to throw. So this function throw if not equal takes two elements. If the two elements are equal, it does nothing, it's a no-op. but if the two elements are not equal, it throws an error. So we've essentially mapped true on not doing something, on not doing anything, and false on throwing an error. So it's already an interesting mapping. And then we do a do block, we do the repeat, and we do try if not equal for each of the elements in the two tuples. If an error is thrown, so if the catch clause is called, we return false. And if the catch clause was never called, then we return true. So it's fascinating to see this syntax, because we have mapped true and false to doing nothing and throwing an error. So it's valid. I mean, it's a valid mapping. Doesn't mean it's like great code, because you could also define a mapping that true is false and false is true. The mapping is valid. You can express the same things than before, but the code won't be very readable. You see what I mean? So that's valid Swift code, and the fact that it's valid Swift code, I find that absolutely amazing. And I really wanted to show this syntax because it's as beautiful as it's awful, honestly. Like, but I'm glad that I've seen it. You know, like I don't regret having seen it. And so if we try to print, so I'm gonna try and add my calls to print around the call site. So here and here, it should print true for the first one and false for the second one. So let's see. True and false. So it worked as expected. I see some comments. So if current value is nil, then you break. I tried to implement the zip method for sequences, but it's partially impossible due to lack of packipation for loops. I put a question about it. So yes, I tried to do it, and I think you end up with the same issue than I had. So that you need to, you basically like you create iterators, like you get a value pack of sequences, then you take iterators from these sequences, and it's when you try to call next on the iterators that you get an issue, because you are not allowed to call next on it. So I guess it's the same issue than what I had. And a comment, a doubt regarding the iteration. Can I just not simply put repeat and use each value as the parameter in something like a trailing closure? So if you don't put repeat, that's a good question. If you don't put repeat, you are not allowed to use each, because each, you can only use it in two places: when you declare the parameter pack, so between these like angle braces. This time I remember the name in English. So you can use each inside, either inside angle braces, where you are allowed to define generic arguments, or you can use each within a pack expansion that you start using repeat. But you are not allowed to use each anywhere else, as far as I know. And you were saying a closure. That's interesting to use a closure. When I tried to use a closure instead of an inner function, it wouldn't work. And there were some type issues. So maybe I didn't like try enough. I think it should work, because in the Swift evaluation proposal, they tell you that since you can refactor any operation on a list, either on a closure or a function, it works. So theoretically, closure should work, but when I tried, it didn't work. Oh, when you say repeat the body, yes. So yes. In that case, what you're suggesting, doing repeat and then a closure. Oh, that's interesting. You know what? I'm gonna try it. Because I want to see if it could work. So I'm going to remove the code of r equal, because I think we've covered what I wanted to show you here. I'm going to paste back the code of total count. And so what you're suggesting is to do something like, let me move it a bit. So repeat, something like that. I think this is what you had in mind. And so here it says, and that's the issue I had, is that when, so when you do repeat like this, I think it's like, I think you have a syntax in Swift where you do repeat and while. Yes, you know, like in some languages you have the do while, and you can do repeat while. It's when you put the condition like at the end. So like the condition is checked at the end of the loop instead of at the beginning. So actually, when I said that repeat was a new keyword in Swift, I think I made a mistake, because repeat already existed, but it's so rare to use it that we just don't use it that much. But I think there was the repeat while in Swift. And so at least the thing is, this syntax doesn't work. which is a shame because honestly, like it would have looked pretty nice. It would have been pretty elegant. And even if I call the closure immediately, like also it doesn't work. So great idea. A shame that it doesn't work. Let's move on to the final example, the one that can be really useful if you use SwiftUI, for example. So if you use SwiftUI, maybe you're using the environment. And I just want to answer this question before. I think repeat plus closures are supported, but just not in that way, since repeat is another looping construct similar to do while. Yes, so you need to find the right syntax, but closure should be supported. At least that's what they say in the Swift evolution proposal. But from experience in Swift, when it comes to like the type system is a little bit more like annoying with closures than with like inner functions. So it's possible that it would work with closure, but maybe you would need like to explicitly give the arguments of the closure and the return type to help the type system. And maybe at that point, like an inner function is like just slightly worse, but not that worse. But I agree that it should work. And okay, repeat, it doesn't unpack the parameters if we don't use it in the pack context. Would have made great sense to use the closure. Yeah, I agree. Like it would have been great, but sometimes we can't have nice things, I guess. And also, I think it drives the point that for me at least, this feature was added first and foremost to lift a long-lasting limitation of SwiftUI. And so I guess SwiftUI didn't need that much this iteration. It just needed to put the values in a tuple. And so that's why the for loop was not supported when the feature was released, because it was not part of the MVP, we could say. But there is a proposal on how to do a for loop for to iterate over a value pack. I skimmed over it. From what I understand, like there are some like non-trivial cases you need to take into account. So it's not as easy as just doing a for loop, but it should be coming soon to Swift. So for the last example, let's imagine that, for instance, you are using SwiftUI and you're using the environment SwiftUI. You know that you can inject things in the environment, and one of the things you can inject are closures. SwiftUI actually does it itself. For instance, you have the dismiss closure when you want to dismiss a model, for instance. But you can also inject your own closures, and that's very useful when you want to inject event handlers that react to a button being tapped, for instance. That's something that is super useful, even more when you are mixing UIKit and SwiftUI, because you can pass a closure that is going to do something at the UIKit level, like pushing a new view controller on the navigation stack, these kind of things. And if you use the environment in SwiftUI, you know that when you define an environment key, you need to provide a default value. And so when you pass a closure, it's kind of annoying because you don't want to forget to inject the actual handler, but it's very easy to forget because we all make mistakes. So what you want to have is something that will let you know if you've forgotten to inject a closure. So for the default value, you would like to have, for instance, a closure that would be something like this, and that would call assertion failure, so that it crashes in development, and that would say a default handler has been called. So you would love to have a function that would be called make default handler, something like this, that would return just a closure. So let me add some line returns. Okay. And then I need to add even a bit more syntax, but this function, it makes a default handler. And so it returns a closure that takes no argument and returns void. So this closure is here, and this closure only calls assertion failure. So if by mistake you end up having this default closure be called at runtime because you forgot to inject the actual correct event handler, so you have the result of make default stored somewhere, and then you are calling it. Actually, I will just call it like event handler. It's much more clear that way. So if you call it in development, you want to have an assertion failure that will let you know that, hey, something is wrong, and you would probably also want to log a production error to using like your logging solution so that you can be aware in your monitoring that there is something wrong in production in one of your builds. So this code works great. It works great up to the point where you need to deal with a closure that makes maybe an event handler that doesn't take no argument. Maybe it takes an argument, like an int. So you need to write another overload of make default handler. And then you need to deal with 2 arguments, and then 3 arguments, etc., etc. And so in the project I'm working on, I had implemented all of these overloads. So there were like 6 or 7 of them, I think. And I mean, they were doing the job, they were working very well. And at some point, I was like, hey, wouldn't this be a great use case for a parameter pack? As it turns out, it is. And it also introduces maybe the last syntax point I want to, syntax element I want to show you. So it's the perfect example to finish because it's both very useful and also introduces one last element. So how can we use a completion handler to define a single make default handler function that will be able to produce closure that take 0, 1, 2, 3, up to n arguments? So first we need to define the parameter pack. So here it's easy, each t, we've done it a dozen times in this live stream, so by now you should be familiar with it. All right, we've defined it. The function make default handler still takes no argument. However, the closure it will return will take arguments, and it will take as many arguments as needed by the declaration of the variable where we want to assign the return value to. So for instance, if we are trying to assign the return of make default handler to a place that expects a closure that takes 2 arguments, then we will have a closure that returns 2 arguments. Same thing if there are 4 arguments or if there are 0 arguments. So here, for the number of arguments the closure takes, it's going to be just our good old repeat each t, because we simply want to have a comma separated list of the types. So here, nothing new. But you can see that it's not enough for the code to compile, because we need to define also the argument list of the closure. And this is where it's interesting, because we want to say that the closure will take that many arguments. And it can be a bit weird to write it, but as it turns out, it's pretty straightforward because it's the same syntax than to define the argument list of a function. Because actually, we are defining an argument list. Just this time, the argument list is at a closure level and not a function level, but it's still an argument list. And so we would do it like this, arg, and then repeat each t. And actually, of course, we need to add in between the argument list and the body of the closure. And of course, since we actually don't use the argument inside the closure, just like with a normal argument, we are allowed to use underscore to signify that, yes, there will be an argument provided, but we are not going to be using it inside the body of the closure. And as you can see, why doesn't the code build? I was thinking like, yes, now it's going to build, will be perfect, but no, it doesn't build. Why not? Oh, yes. It's because I didn't say what the types are anywhere. So I still need to say, hey, actually what I'm expected here, it's a closure that takes no argument and returns void. This time it builds. So this is my event handler 1, but I could also say, all right, event handler 2, this time it will be int to void, and 3, it will be string and int. And you can see that the closure produced is of the correct type. So void to void, int to void, and string int to void. So if you use SwiftUI and you use the environment to inject event handlers, this is a pattern that you can basically integrate in your app straight away. And it should be quite useful because it will add a nice level of safety in case you forgot to inject an actual event handler. And it won't be like that difficult to add, because it's just like this function make default handler. So it's literally 5 lines of code that you need to add somewhere in your project, and then call this function whenever you need a default handler that is not supposed to be called. And when it's called, it's definitely a mistake. And so it will do an assertion failure, it will log an error, etc., etc. So I was quite happy to finish the live stream with this example that I found only recently, because many of the examples, they were a bit abstract because their goal was to introduce a syntax rather than an actual real world use case. But this last example is very real world. It's something that I've been able to use myself in production last week. And so I hope that it will also be useful to you. And that being said, it's the end of the live stream. So I thought it would only take 1 hour because this took me only 1 hour at Swift Island. But thanks to your question and the fact that I took like a little bit more time than at Swift Island, it was 1 hour and 40 minutes. So honestly, that's quite good. Quite good when I think that I covered parameter packs in 10 minutes at Swift Connection 3 weeks ago. That was really like a very condensed version of what we've seen. But I see that in the chat that you've enjoyed this live stream. So thank you for watching it. A replay will be available very soon. Feel free to share this with your colleagues if you think it could help them. If you have suggestions for future topics I could cover in a live stream, please feel free to let me know. I am planning to do a live stream on macros. I don't know when, because it's more a question of when I will have time, but the content is mostly ready. So I did a live stream to discover macros during the WWDC in June, but this time it will be more about how to implement a macro and go at it step by step, and with like more like better knowledge than what I had only 2 days after the announcement of the feature. So that should be the next live stream on the channel. I think I've reached the end of this live stream. So I guess I just have to say thanks a lot for watching. Thanks a lot to all the people during the live stream who asked questions, who gave remarks. It makes it super interesting for me. It makes it very interactive for me, and that's really great. And I'm sure that this question will have helped the people watching the replay. So I think on the behalf of all of those watching the replay, I can also thank you. And I just have to say, have a great evening, rest of your day, depending on where you are in the world. And see you next time for another video or another live stream. Bye-bye.